Hey, what's up, Franklin West? I have part 3 of 3 for you when it comes to solving for the surface area of a rectangular prism. This is certainly in the extension realm, so anyone at any level can take a look at this. This is a chance to take this knowledge of how to calculate areas of each face of a six-sided figure, add them all up, but to do so with a variable. So we're not going to get numbers like 164 squared inches. What we're actually going to get are answers that have multiple terms. So like 6x plus x might show up in there, or x squared, 2x squared plus 2. So there's that added challenge, and we'll bring it even further by then asking, well, if this is the final total area with all these x squareds and x terms, what if we did know the value of x? What if x was some number? Well, then we're going to evaluate the polynomial we create by plugging in that number in for each x and then following order of operations. So if you are really hungry for another layer of challenge and you're looking toward high school level work, well, then this video is for you. We are not going to do units with this, but certainly you could create for yourself your own problems. You could just make them up and get them checked by a peer or me if you wanted to. You could make up all these layers, so you could have fractions and decimals together in a problem with units that you have to track and convert those units, or maybe you've got variables in there too. So you see how you can add all kinds of layers to your work in order to execute more challenges at once. But there's nothing wrong with practicing each challenge separately as well. And so with that in mind, we are not putting in units with this algebra layer, but if you're hungry for that, you go for it. All right, I hope you enjoy the video. All right, here we are. Here's our final rectangular prism, calculating the surface area, and we're adding that extra layer. So we are beyond the proficient. We're looking at extension. What if we have terms that represent the edge lengths of our figure, and we don't know exact values? Well, you're going to see that our protocols in terms of what we did in the last two videos are exactly the same, but we're going to start to create things that expand into many terms rather than have one consolidated numerical answer as our result. Okay, so I've already prepped this and labeled it. So this edge is a 3x in length, this dimension is 2x in length, and this one is x plus 1 in length. And so what we should do is put together our collection of paired faces and all their product areas. So we've got a 3x by 2x, and we have two faces there. So 2 times 3x. And actually, just to make it simpler so I don't have to do those dots again, I'm just going to put them each in their own parenthesis grouping. So this is 2 faces, 1, 2, that's this 2. And then 3x by 2x, this is the area here. Okay, now I'm going to add to that another layer of work. We have this lateral surface. That is the 3x edge by the x plus 1, and I have a second copy of it. Its twin is over here, so 2 faces times, what did we say that was, the 3x times the x plus 1 dimension. All right, so now we've got the top and bottom, which we know again are in pairs, so the top and bottom. That edge is 2x, so 2 times 2x times that long length, that's x plus 1. And actually, I'm noticing as I had just made this up on the fly, this is definitely not drawn to scale, is it? Because if this is all the same x, and they are, we get to assume in this context all those x's are exactly the same, so whatever their value is the same. These two surfaces, or sorry, these two legs here are much bigger. This one's tripled and that one's doubled, and this is just the base plus 1. So this would not be so elongated. This would be a much wider, shorter figure than as written. And that's common. We're going to find that. We can't always assume we're drawn to scale. Okay, so again, don't let this layer of the algebra information throw you. do what you know you've been doing. You've got to multiply these together. So let's just break it up. So let's take a look at all of our constants and coefficients and multiply those together. We've got 2 times 3 times 2. So I know that 2 times 3 is 6, 6 times 2 is 12. So notice I'm just breaking it up here. So I'm going to have a 12, and that is going to be times x, which is x squared. And I think I am going to take a moment to draw in the power rather than try to type it and shift it. So I've got 12x squared here. And because I think I said it in the intro to this video, I'm not going to track a unit of length with this work, just because we're going to focus on the algebra. But certainly you can take a look and see a coefficient, a variable, and a unit would be a lot to track. So there are ways to add in more layers if you're looking for it. All right, the next one, because of this term here, I'm actually going to multiply these two together first just to consolidate them. So that's going to become a 6x, and that, as our scratch work, I'll just write it above here. So I've got 6x, right, 2 times 3x, and I'm going to just keep this as an intermediate step. I'll times the quantity, that is x plus 1. Now, if you took a look at any of the how to solve linear equation videos that are on the channel, you might have already seen this before and know exactly what to do. But what we have to do here is something called distribution, which is a multiplicative property, where we're saying that this x plus 1 is some quantity that's broken up into 2 parts, and each part needs to be multiplied by the term that is right outside that parenthesis grouping. So I actually have a 6x times x, which should get us, I'll just keep it in red, 6x squared. And then a 6x times 1 is actually a 6x. Because it was a positive times a positive, I get to write that it was a positive 6x. And so what that does is it has the first term adding to the second term. Okay, and so let's type that in there actually. So it'll be 12x squared plus, 2 terms now, 6x squared plus 6x. So see that it doesn't actually get simpler, it actually gets a little more complicated looking. So I've got 12x squared from this multiplication. 6x squared plus 6x came from this here. So I guess we did shorten it a little bit. There was some consolidation here, but certainly we did not get down to 1 term. And we're going to repeat this process, this third step of the last 2 faces here times their dimensions is going to look a lot like what we did in the middle. So I would recommend do 2 times 2x, so that gets us a 4x. And then we're going to have, I'll just slide that over, 4x, it'll be multiplied to that same quantity, x plus 1. And we're going to do our distribution. Let's go to purple. 4x times x and 4x times 1. You really have to do both, okay? Otherwise, we're not going to retain the real original value. So that is 4 times the 1 not written, so that's 4. And x times x is x squared. Whoop. And then 4x times 1, anything times itself is or anything times 1 is itself. And so we just get another 4x. So we're going to add those together. So plus 4x squared plus 4x. Okay, so we've consolidated here. 12x squared plus 6x squared plus 6x plus 4x squared plus 4x. So we really are at the point where we want to combine like terms. And so x squared terms can only combine with other x squared terms. And so as you can see, I'll go with yellow, there are 1, 2, 3 x squared terms that go together, and then x terms can only add or combine together. We got lucky, everything is just a positive here, so we don't have to worry about signs in this example, but that would be another way you could add an interesting layer here. So according to our like terms, we have 12 x squareds here, 6 of them here, and 4 of them there. So I like the 4 and 6 making a 10, so I might combine those together first. Plus 12 gives us our 22 x squared. And then we have our x terms. We have 6x plus 4x will get us, well, I'll just go right in there. I don't know why it does that automatic punctuation there. I'll just expand out a little bit more so I have some room. That'll get me my 10x. So 22x squared plus 10x is what we consolidate down to. And actually, without any more information, guys, or everyone, I shouldn't say guys and girls, folks, without any more information, this is our final answer, 2x squared plus 10x. And so notice it doesn't get us one term. But let's now add, as if there was this direction this whole time, what if we did in fact know the real value of x in this problem? What if we were told that x was equal to 4? What could we do now? And actually, let me add another layer. With that information, what is each dimension of our rectangular prism? Okay, so let's have that be our focus now. This is going to get into another great algebra skill, and that is the ability to substitute a value in for the variable in an expression you have created. And so right now this represents the total surface area of the rectangular prism. But now let's say, maybe I'll do some writing. Now let's say we know the value of x, and so we're going to do 22 and it's times, so I'm going to use parentheses because I'm substituting 4 in for x. Whenever you substitute, parentheses are your best friend. Okay, notice I wrote the first term exactly how it was, but now that I know that x is 4, I've replaced x with 4. And I'm going to add to that the next term, and that x is also the same x in question from before. It is worth a value of 4. And now we follow what's the order of operations. So we do exponents first, right? We're not going to do 22 times 4 and then square it. That would be an obscene number and would violate our math rules. So this is 4 to the second power. So 4 by 4 is what that means. So 4 times 4 is 16. I'm just going to break it up in steps. You may not need to do this. You may already be ready to go to the next layer, but just so I can make sure I'm outlining all the thinking anyone might need, I'm going to show that 4 squared is 16. So I also did 10 times 4 is 40 and got that consolidated also. So 22 times 16, you could throw into the calculator. You could try some mental math. You could scratch it out on paper. You should do the method that best supports you where you are at in your learning. And so now you have 352 plus 40. And that should consolidate all to 392. Take a moment and see how all this work was organized. It's all organized vertically, coming to really a point, a final answer. This is what you need to demonstrate your thinking in a very clear way to someone else. And plus, each line is equivalent to each other and to the original problem above. And so this pathway from final answer up here continues. See how it goes all the way to the beginning? 392 when x is 4 is equivalent to this whole big line, right? And so you want to steadily whittle your work down as to the simplest amount of terms as possible. Okay, and that is really good form in math class. Okay, so we've got our total surface area in a numerical component when we started in variables. And that was only possible because the problem provided us with this additional information of x's value. So let's take a look at this problem right here, this question. With that information, what must then be the dimensions of our rectangular prism? Well, We know the total surface area is 392. Let's go over here and say, all right, if x is 4, then this is 12, right? Because 3 times 4 is 12. If x is 4, then this is 8. And if x is 4, this length, which looks really impressive, is actually just a 5. And so this brings us back to how the video started, of recognizing that we can't really assume that our figures are always drawn to scale. So be careful with what assumptions you bring into your work. So this is the end of how to calculate surface area of rectangular prisms, and with the added layers of algebra to get you into extended learning. So I encourage you to find additional resources to practice. There's a plethora of resources online. Communicate with your teachers and see what it takes to support and extend your learning. Great job driving your education, everyone. So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people, and we'll stay in touch.